I get the fun part now to welcome our first plenary speakers. So Eric Stade is a professor of mathematics at the University of Colorado Boulder. David Webb is an associate professor of mathematics education, also at Boulder, and I believe he's the director of the Freudenthal Institute here in the United States. Angie Hodge is an associate professor of mathematics, and you may remember her from being a co-chair of this meeting last year and the year before. Yeah. And she's the University of Nebraska, Omaha, and she's the George Haddock's Community Chair of Mathematics, which is an outreach kind of position, which is nice. So my own personal challenges with inquiry-based learning at this point in my career, I feel comfortable with classes for more advanced students, where proof is the way to go. I feel comfortable with that. I've even become comfortable with classes where there's no way that proof will ever be a part of the class. Like one class I teach is math and decision making, and the students are generally math phobic. And I've used IBL as a way to aim at those students because it frees them from some of their old patterns of thinking. But one place I find really challenging is to hit that middle zone where you have first and second year students that are expecting a traditional calculus or linear algebra class. And this is my new challenge. And so I'm really excited to have our three speakers here today. Angie, David, and Eric, please.
So you can read the directions on the screen and get started. We'll give everyone about 10-ish minutes to work together. We purposely only have 2 per table, so you have to make friends.
The cards.
Work on the cards.
In groups of 3.
Organize them in a way that makes sense to you. Okay? Okay, go ahead and get to a good stopping point. And we recognized when we gave you this activity that you would not be able to finish in the amount of time we were going to give you. We wanted to give you, though, a little bit of a teaser and a taste of some of the activities we've been developing together and using to promote IBL in our classrooms in pre-calculus, calculus, and Calc 1 and Calc 2. I want to, before we get to some of the other parts of the presentation, now that you've had a sense of this activity, what was our role? So Angie, Eric, and myself, what was our role as instructors in this activity? Ideas?
Cindy York, and the instructions said to work in groups of 3.
Annie Selden, New Mexico State. What you did was design the activity. There's a lot of preparation ahead of time for IBL.
Yes,
Thank you.
yeah. So that not to say, oh, there's no teaching involved. There's this, in the planning side And this is deliberate. We wanted to develop an activity that would promote a response from you as student. We wanted an activity, and we have a handful of these, quite a few of these in fact, where I call it low instructional overhead, at least on the front half, where it doesn't take much to get you started. And all we asked you to do is get in groups of 3 and organize these in a way that made sense to you, and it promoted interaction. It promoted interaction amongst the room. Promoted interaction amongst folks that are at tables with strangers that are now more well known because you introduced each other and yourselves. We do some of these activities in the first week of a Calc 1 and Calc 2 class to set an impression and a norm that this is going to be a little different than what you might have expected from a university calculus course. I want to actually focus also on the cards themselves and the design, as Annie pointed out. So which pairs, maybe just think about how you organized. Which pairs or triples did you do first and why? What did you save for last and why? How did you get organized? What was your strategy for organizing these? Any comments from the group? Some hands up.
Amanda Matson, Clark University. We figured that since we were in groups of 3 and there were 3 colors of cards, we would each take a color, and then we would look for key features, like the period of 2 pi is very straightforward, and get those done first.
Nice. Okay.
Yeah.
Gary Richter, Southwestern University. At our table, we use the jigsaw puzzle approach. We put the pieces out, face up on the table, and then the 3 of us just looked for things that matched.
Okay. And across the colors? Across the colors, okay.
John Ross, Southwestern University. We ultimately decided to match the functions with their derivatives, so the green and blue cards, and then went from there.
So saving the orange or salmon color for last. Yes.
Exactly.
Ellie Kennedy, Northern Arizona University, and we conversely went with the orange ones first because they seemed to be a more difficult concept, and then matched that to the function.
Interesting. Started with a more difficult concept first. One more comment.
Elona, South University, we actually started with the orange card first. And we said, let's see now we can go backwards and target a little bit more challenging than we did.
It is descriptive in a different kind of way,
Yes.
right? Compared to the
We were
graphs.
only 2 and not 3.
Okay.
We didn't have any
So a diversity of approaches in terms of strategy. Some other questions that we would ask students as part of a debrief, in particular, well, there's one right here. That's card 7 from the blue one. You can kind of see it there up on the screen here, this one. Why is this graph not a parabola?
Raise your hand. We can
Too flat? I'll just pull some people out. Too flat? Anything else? Why is this not a parabola? Yes? Its derivative is not... Well, process of elimination. You didn't find its derivative. Okay, so this was a function card. You didn't find any match in the derivative card. Right, and an expected derivative would have looked like what? A what? It would have looked like card M, but slightly different, right? In terms of position, maybe. I'm just keeping mindful of the time. I'm going to switch back to some things here and also discuss a little bit more on some questions that we would pose to students. We do realize that the activity itself is engaging. Necessarily, that's what we're trying to design here. We want to promote interaction, and we want to promote mathematical discussion, and have students share the patterns that they see, the relationships they see, and engage in some degree of relational reasoning with this piece of content. But then the debrief is also important too. The questions that we pose, and some examples are here, of the types of questions we would want an instructor to offer to students to try to get some closure to the activity, but also to push further with what they may have learned from their brief tour of some of these relationships. So the debrief is critical. The introduction, not so much. The introduction just gets you started. The design of the cards is very important. Again, the low instructional overhead piece. The instruction happens here. The role of the instructor is important in terms of offering certain probing questions with certain groups, seeing what they notice, but then also pulling the discussion back together. So this is one example of a range of activities that we have designed, that we have included through our calculus courses, and we continue to design and modify. I'm going to step back a little bit, and actually, this was the original title of the talk, but of course, not as many of you would have, this is kind of an obscure title, but this actually gives you a sense of the types of things we'd like to talk about. In addition to inquiry-based learning, our collaboration has come through a partnership called the Math Teacher Education Partnership, and it's been organized around calculus, at least with our group, and then how has it affected ourselves individually and collectively. So we also like to gratefully acknowledge not just the support from our own universities and APLU, but also the Helmsley Charitable Trust, the Educational Advancement Foundation, and Academy of Inquiry-Based Learning. We wouldn't be here otherwise and enthusiastically engaged in this kind of work without their support. So this is not a solo endeavor. I think it's really important that you find like-minded colleagues who can share ideas. And I think back to the time where we were doing some nice things at University of Colorado, but until we invited Angie out, and she gave a brief demonstration of a TACTivity like this with our graduate teaching assistants and faculty, that we realized, oh, there's actually quite a bit more we could do with instructional resources. And that only happened, I think it was about a year ago. We've only been at it for a year. But we've co-designed activities together, and you're about to see over the course of this presentation the scope of things we've designed that actually are going to be available for you to use. I think at this point, I'm going to shift here, and Angie.
Okay, so I'll give you a brief overview and then talk a little bit about the partnership that David mentioned. So we're going to start out by talking what created this UNO-Cu-Boulder partnership and connection that helped us to go from people who just met each other at a conference to people that actually work together and collaborate on a very regular basis. And then what is the connection to IBL? You'll hear us use the term active learning and inquiry-based learning both. We'll actually talk about what is that connection. And then what does undergraduate mathematics look like at Cu-Boulder? People have probably heard me talk about what it looks like at University of Nebraska, Omaha enough or before, and if you haven't, you can always come ask me. So we're going to focus on the change that happened at Cu-Boulder, since it was such a dramatic change in just a year's time, to see where they were and where they are now and how you can make this transformation in your calculus department with in a very short amount of time. And we're going to share some activities for the calculus sequence. We've shared one. We will share a couple more, and there are baggies. There's enough of the activity you did today for everyone at the table right outside of registration, and we have 2 more activities, probably enough for half of the people, and we'll give you a website that has several other activities that have been created and piloted in our classrooms. We're creating more. We'd like to pilot those before we actually put them live. So if you're wondering why isn't everything out there, we want to make sure that there aren't some big goofs in there before we put it up for the world to get. And then what you can do to make your own calculus class more active. So the Math Teacher Education Partnership, I was asked a few years ago now, I guess it was, to be part of this, and Jim Lewis was the person who led the MTEP in Nebraska. And since I was already very interested in teacher education, I said yes. I had no idea that it would have a connection to inquiry-based learning or active learning at the time. We all went to a conference. Now it is, the website says 103 universities, and I think it might even be bigger now after the conference this last week there. 142 at least K-12 schools participating. And you can see some of the list of what the partnership is set up to do. So this is really to make inquiry-based learning and active learning a part of the K-12 school systems, not just the universities, but what we can do at the university to get that to go down. So you can see it endeavors to build a national consensus of guiding principles for the preparation of math teachers, promote partnerships among sectors throughout teacher development process, and that's university to university, university to K-12, kind of all over different partnerships, develop and coordinate a network-related and development agenda, serve as a clearinghouse for model programs and practices, and advocate for change at the university and state and national levels. So making actual real changes with a purpose and plan to kind of promote a big change for a lasting time. That's a little picture of some of the universities on the map, and it's growing. So a question was asked. My very first MTEP conference I went to, they left us with a chore of saying, how can we increase the number of teacher candidates produced, improve the quality of math teacher candidates, improve student success in the beginning college mathematics and what their feeling of going through a beginning math class is like and their experiences so they don't drop out, and in general improve secondary math teacher preparation. Any idea of what can help do all of these things that was already happening? Anybody? You can just shout it out. IBL. So they asked us all how we can do all these things, and me being an IBL person there, IBL came to mind. I was hired at UNO to University of Nebraska, Omaha to do these things in my classes, and had started doing this in calculus. And so Jim Lewis and I sat together at a table, and we were supposed to come up with research action clusters, and we talked about focusing on inquiry-based learning for these things. And I think Eric was kind of misplaced. He didn't have a group on where to go, so he decided to join us. Maybe he actually wanted to. I'm not sure if he actually wanted to or not at the beginning, but he did get stuck at our table. So the three of us came up with this active learning research action cluster. And active learning is just a fancy name for IBL. Some people in the education world are a little bit scared by the inquiry-based learning word, so we just gave it a new word. And to make your classes more active, it's the same thing. Just a different word, hands-on, minds-on. We wanted it to be various entry points, but something that could go to multiple universities and could become part of a teacher prep program and also affect the whole how university calculus is taught. Why the calculus sequence? As you all know, there's a high DFW rates in calculus. People take calculus. Some universities even use it as a weed-out course. So we wanted to change that and have it be a success for students and a good experience for them to take more math versus them dropping out after taking a calculus class at the university level. And also to help get more majors, use it as a recruitment tool and to develop our secondary math teachers by giving them an experience early on that we're already telling them that they should do in their education classes. Just one preview of the results, and then I'll hand it over to hear more about the program. This was from one of my students in fall 2014. Instead of sitting and taking notes all day, you get involved and interact to learn the material, which helps you actually learn and retain the knowledge.
So I thought I would give you a little more information on how we do calculus at Cu-Boulder. This is intended as an example, of course, because different institutions have very different needs and circumstances, and you have to find a program, of course, that is tailored to your institution and that will work for you. This works for us. So our Calculus 1 and 2 meet 5 days a week. Angie mentioned that things have happened very quickly at Cu-Boulder, and in a sense that's true. But I should mention that the first sort of initiative towards active learning that we engaged in was almost 25 years ago, where we, in fact, gave up a couple of faculty lines so we could convert all of our calculus into small sections. Quite a big sacrifice, but we think it's worth it. It seems to have worked out. Those small sections are taught mostly by graduate students, capped at 35. So we have a couple dozen small sections of Calculus 1 in the fall, and then maybe half that many sections of Calculus 2 in the spring. Almost all those sections are taught by graduate students. As I said, it's 5 days a week. 4 of those days are what you might call the lecture section, although less and less lecturing is done in the lecture sections. Thursdays are recitations, and it used to be the case that no one ever went to recitations because it was led by a TA and attendance wasn't taken, and you know, the only time students would go would be if there was homework due on Friday, and then you'd go to recitation and ask the TA, how do you do problem 5 on page 193 or whatever. So we've completely replaced that kind of recitation with active learning group projects, which last the whole period. The lectures, again, as I mentioned, kind of half and half, kind of a hybrid. So some lecturing still goes on, but I would say depending on the instructor and on the class, the lecture will be somewhere between, I don't know, 25 and 75% lecturing, and somewhere between 25 and 75% group projects, active learning projects. We do have, and we consider this key because we have so many sections being taught by graduate students, we have a dedicated faculty position who is our calculus coordinator, coordinates the small sections, oversees the exams, and provides quite a bit of professional development for the graduate students. They're not just thrown into the classroom, they're given professional development, much of which is aimed at making them into active learning IBL instructors. We also use learning assistants in our classes, and I wanted to give a particular shout out to the Learning Assistant program because we believe it's a key weapon in the sort of active inquiry-based learning arsenal, and we believe that learning assistants are transformative both in terms of course content and course pedagogy, but also in terms of cultural norms in the department and at the university. So these are undergraduates who are hired to assist with course transformation and with group work. Thank you, David. Yeah. They get quite a bit of professional development themselves. They take a course in the content from the math department. They also receive a pedagogy course, training in pedagogy from the School of Education. One of the agendas of the Learning Assistant program is to get more STEM majors, this is not just in mathematics, but in a variety of STEM disciplines, to get more undergraduate STEM majors interested in careers in education. So this is a way to give them some experience with teaching others and with helping others learn the material that presumably they know and love. We have, by the way, quite a bit of data that this agenda item is successful, and since we've been using learning assistants in mathematics, we have tripled the number of students seeking secondary licensure during that period. So that's been quite a joy to us. As I mentioned, it's not just in mathematics. In fact, the Learning Assistant program, which began at CU, did not begin in the math department. It began in astrophysics. The program itself did start at CU, but has been replicated nationwide. In fact, there are now 60+ colleges and universities using learning assistants in one or more departments. At last check, 26 of those departments were math departments. If you're interested in learning more about the Learning Assistant program, there's a website right there. And by the way, this presentation will be posted online, so you can just click. Tells you all about how you can receive more information. There are workshops that are given nationally on how to begin a Learning Assistant program in your institution. As I said, in my personal opinion, the Learning Assistant program and the use of learning assistants has been absolutely transformative for us. So moving on, we wanted to give you a little taste of some of the other activities that we use in our classrooms. By the way, I believe Angie and/or David used the word TACTivity, and that's our clever little term for activities that have a tactile component to them. So a number of our activities are tactile. And the one you just did is tactile. We have this definition of the derivative project where there are various steps in the computation of a particular derivative using the definition. The cards are given to the students completely randomized, sorted all out of order, and the job that they have to do is to sort these steps into the appropriate order, like this. This is a fairly short activity, and again, in our lectures, so to speak, we often give, as either a start to the class or as a way of wrapping up, we'll give short little activities like this. This one takes maybe 10, at most 15 minutes for the students to do. But we also have follow-ups, so if you wanted to make this into a longer project, perhaps one to do with the entire period, we have a worksheet that sort of follows up on these basic ideas. So page 1 is basically doing what they just did, but in a form where they can write it down and have something to take home with them so they know what order the steps go in. The next page, the steps are all spelled out in order. I guess it's a different computation, but a similar computation. They're spelled out in order, but at each stage there's a right statement and a correct statement and an incorrect statement. And the students are asked to identify which one is correct and to explain what's wrong with the one that isn't. Then there's a fill in the blanks, and the last one is sort of completely DIY, just do-it-yourself definition of the derivative. So there's sort of a progression towards guiding them to the point where they can do these problems entirely on their own.
Another example of a TACTivity would be we made some dominoes. I think that actually this one is available on the table.
It is, yep.
So this comes later in the course, definite integrals domino project, and you'll see various representations. So again, there's very little instruction up front, but students look for key features on graphs, on statements, on integrals, and identify which of these match up, and you get something that looks a little bit like this. Now, of course, most of the time, and also the other video, students are talking with each other. We're not going to show you video clips of the entire conversation that would typically happen. We don't have that kind of time. But at least to give you a sense of the type of reasoning that match these up. So there's also some self-reinforcing things in terms of the feedback if you make this all together the right way. So there's these TACTivities. There's also, that's not the only thing we've done. From the Thursday sessions, from the Thursday recitations, Eric talked about the Learning Assistant program. Because we were going to have learning assistants in the class, we wanted there to be more group-worthy tasks, tasks that were worth talking about. So there was the development of activities that started with the problem context. And this would be an example of one of them. There's a number of these where students, they aren't told what approaches to use, but they're given a problem context and asked to mathematize it. There's some scaffolding along the way, and in fact, I think Eric's going to talk a little bit about this one.
So one of the precepts of inquiry-based learning is that students should have the opportunity to engage in rich mathematical experiences. So a number of ways in which we try to enrich the mathematics is through providing authentic or realistic contexts. This particular activity uses data that's taken from solar panels actually installed on an elementary school that's local to Boulder, and asks the students to use this data, given to them in graphical form, to explore the relationship between power and energy on the surface. Of course, more deeply, they're exploring relationships between derivatives and definite integrals, between functions and their accumulation functions, using such devices as Riemann sums and graphing of the accumulation function, and identifying the area under the curve as being the integral or an antiderivative of the curve itself. So the green curve here is power generated by the solar cells, and the red curve is power consumed by the school. And using this actual data to explore these big ideas about, in a sense, the fundamental theme of calculus, derivatives and integrals and the relationship between the two. On the topic of authentic or realistic contexts for mathematics, I wanted to also mention briefly a new course that we've developed at CU. We call it Calculus Systems and Modeling. Actually, this course has recently been picked up by UT Austin as well. They have a different name for it. It's basically a calculus course for students in biology and the life sciences. What we're looking at here are actual data from an experiment, a simulation we do on the first day of classes, using handshakes and poker chips to simulate spread of a disease. So the students mingle and they shake hands, and if you have poker chips, you give some of those poker chips to the person you just shook hands with, and that simulates the spread of a disease. There's a recovery period. If you shake hands 5 times, you you're recovered and so on. So we chart the evolution of the three subpopulations here, the susceptible population, the infected population, and the recovered population. This is the first day of classes. The next, during the first week of classes, we launch in right away towards constructing the differential equations, the system of differential equations that model this phenomenon. It's a well-known model in epidemiology, the SIR model, susceptible, infected, recovered. We developed the differential equations. They do not admit a closed-form solution, so we get the students programming using Sage, which is a web-based, open-source mathematics software package. We get them to generate numerical solutions to this system and similar systems in population growth and gene expression. One activity they particularly like is modeling fermentation of wine, things like that. But I should point out that the programming and the numerics are not ends in themselves, but they are contexts for exploring the really deep, rich mathematical, if you will, the traditional calculus ideas. And in the end, they are able to write programs where they can produce graphs like that.
So just a couple things. The work on the Thursday recitations over about 7 years, I would say, is how long the Learning Assistant program has been in place. That type of curricular work, instructional material work, starting last summer when we met with Angie and started developing TACTivities, it came to us that, well, why aren't we using more of these Thursday activities across the course? So actually, that's what happened last May. We started redesigning the Calc 1 course to integrate more of these projects so that it wasn't just in the Thursday session, it was part of the regular lecture. Now the lectures have become more IBL oriented. The lectures, actually, as Eric said, depending on the instructor, we've planned actually 60% of the Monday, Tuesday, Wednesday, Friday sessions to be involving some of these projects and activities. How they're implemented, we've also been monitoring that using observation protocols. And it varies from 25 to 75%. And even some sessions where instructors, graduate teaching assistants, would typically maybe give a more teacher-directed approach to a topic, we see others saying, well, I can do this a little differently, and they're bringing students up to the board, and they're having Q&A periods where students are questioning, critiquing each other's work, where maybe their colleague in a different section might be doing something a little bit more teacher-directed. So it is starting to trickle out and influence the planning and instruction. We started that before the fall 2014 semester. What you see below is just a brief chart. It's not a trend yet. I can actually go backwards to show you the trend before. We had a persistence rate of students that would take Calculus 1 in the fall. We would get an enrollment in the spring in Calculus 2 of about 50% of that number. And this year it jumped about 12%. There's other things to look at, but it certainly is promising. It didn't go the other way. We have more sections of Calculus 2 than we've ever had before, and that's going back 10 years of data. And students, the faculty course questionnaires, the course evaluations are at an all-time high as well. So that's in one semester that we noticed a difference. And if Fantone was here, she could describe how she took some of this motivational data about the success of the program, and it motivated her and Angie to almost, just between the two of them, co-develop Calculus 2 activities to make sure those were ready for the following semester. So we actually have Calculus 2 activities as well and projects.
And I have to say before I put the next slide up there that it definitely truly was a partnership. So if you've been doing IBL for years and someone comes up to you and asks you to go give a talk and help get started, we did not have learning assistants at the University of Nebraska-Omaha until I partnered with Cu-Boulder, and now we have learning assistants in our classes, and it's helping us to recruit math majors and also help those people be better teachers in the future too. So we hope to learn from that and develop IBL future teachers or people going to graduate school in math too. So the partnership helps you learn as well, and I would not have all these materials created if I didn't have people to work with. So besides the data, the numbers data, Sandra Larson has this activity called Roses, Buds, and Thorns that she let me use, and every semester the information that comes from there is amazing. You ask your students to write about a rose, something that's going well, a bud, something that is growing or it has grown, and a thorn, something that's still sticky from them. And I just picked one of these, but we have lots and lots of these quotes, and every one of them, even if they don't necessarily like IBL, is a positive thing you can learn from your students. And I like this one in particular. It says, Rose, this course encourages collaboration, which if you find the right group mates is really fun. Thorn, homework is how I solidify my understanding of a topic, but sometimes when the homework is due the next day, I don't have enough time to properly do it, which means I rush through this and may miss something important. I've fiddled with that, having 2 days to do it assignments. There's, you know, sometimes it's okay, sometimes then the students don't do their homework, but at least the student realizes doing homework helps me learn, which is something that is very important for freshmen to learn. And a bud, this course has really helped me to become an active learner. A problem is presented, and instead of being taught exactly how to solve it, you're required to think through it. And almost every one of them, even if they didn't necessarily like active learning or inquiry-based learning, in one of their 3 said, I now know how I'm required to think, problem solve, persist, and I am now a better thinker. So that's a very positive thing. And I will leave it with Eric, and then we'll have plenty of time for questions.
So, you know the definition of an extroverted mathematician is one who stares at your shoes instead of his own. So we are fairly extroverted as mathematicians and as math educators, and in particular, we really like to share. So with that in mind, we've put together a web page, the URL is right here, where you can find the activities we've discussed here today and a whole bunch more. We've tried to put together enough in both Calculus 1 and Calculus 2 to kind of take you through a semester. Certainly there are gaps there, and by the way, please share our love of sharing. So if you have ideas for how to fill in those gaps, please get in touch with us. If you have any questions and need more information, these are our email addresses. And by the way, while we're mentioning this, I also wanted to make sure we gave a shout out to 2 of our colleagues who aren't here today, but who put a tremendous amount of work into all of this. David mentioned Fantone, that's Fantone Liu. She is our dedicated calculus coordinator person. She's kind of in charge of this whole mess, and it is a big mess, and we sincerely believe that having that dedicated person there makes all the difference. In particular, Fantone did a lot of work in putting together this website. My colleague Rob Tubbs is a number theorist in the math department. He was chair way back 25 years ago when he made the decision. By the way, he didn't tell anybody because he probably never would have gotten away with it. But he made the decision to trade in a couple faculty lines to A, grow our graduate program, and B, to be able to offer all of our calculus in small sections. He's still at it and still a huge part of what we're doing here. So big thanks to Fantone and to Rob as well. And finally, we just wanted to say thank you all for coming and for listening to us today.
So we have some time for questions you might have about the program, these activities. Want to circulate the pen?
Hi, I'm Susan Crook from Loras College in Dubuque, Iowa. It's on the coast. I was wondering, how often do you do the roses, thorns, and buds in class, Angie?
I try to do it twice a semester. Sometimes a semester flies by and it ends up being once a semester. I count it. I have it on my IRB that I can count that as a quiz, so they actually do it.
Valley State. I was curious as to all of these activities you've mentioned are awesome. They do kind of depend upon being in the same room at the same time. And so I was wondering if any of you have tried or speculated about how these would translate into a hybrid or online course.
I taught a hybrid course last semester, so I'm fully aware of what that could entail. I think definitely the project sheets and discussion board interaction, even though it's asynchronous and it's different, could work. The TACTivities, I am not sure how that would work. I think that would be very, very difficult. Although there certainly are some ways to get some of these TACTivities developed in electronic means, where you could have people coming together and work on it in assigned groups. We haven't done any of that. We haven't even talked about it. It's the first time I've even said those words myself. So if there are some innovative programmers, they could take some of those ideas and develop some similar activities online where people can come in together and work on those. If you go to the Desmos website, some of you might be familiar with that, there are some similar types of activities where a group can very quickly be assigned and see each other's work and comment on each other's work, and there's similar tools there. But that's a lot of computer programming talent and capacity that our project really doesn't have, nor we haven't really considered it. But the project sheets, like the solar panel activity and a number of other ones, absolutely, you could have those be presented to a group and they discuss together on a discussion board. And the nice thing about that, in contrast to the discussion that happened here, is that discussion is captured. Whereas the discussion that happens here is memorable, but not captured.
There's one thing I do in my classes is everyone works at different paces. And so I post these on Blackboard if they want to print them out, cut them out themselves. And the way that we have them structured, they're actually set up as a key so you can check when you're done. So a student can print them off, cut them out, and try them on their own if they think their group went too fast or if they want to practice before the exam as well. And I think Sarah Marie had a question next.
Actually, I have two questions. One's really, oh, sorry, Sarah Marie Valcastro. I'm not from, so. So first, quick question. When you're doing the TACTivities, do you actually bring in everything cut out, hand it out, and collect it afterwards? As opposed to leaving them and giving it to them to keep?
We collect it, yeah.
But my real question was, so this new course with the SIR model and fermentation of wine, was that a rewriting of calculus in context, or was that done completely independently of the NSF project?
The former. So no, it's the calculus in context course, yes. It's been brought up to date in a variety of ways. For example, we use Sage instead of handheld.
Thank goodness. Kudos to you for doing that. Is it available to other people to?
I can, there's a Dropbox, and I can share the Dropbox with you, sure. Be happy to do that.
Awesome.
Just email me, last one right there, be happy to do that. Yeah, so just I mean, I certainly don't want to, I certainly want to give credit where credit is due. This is a course that was, there was a project called the five college calculus project some 20-something years ago that developed this calculus course and a text that goes with it called Calculus in Context. Unfortunately, in a sense, that text has gone out of print, and I guess it didn't catch on. The upside of that is that the text is available free online, and I can certainly tell you where to find it if you want. And so again, we've updated this course. All the materials are there. Anyone who's interested, please do let me know.
One of our partners is University of Nebraska-Lincoln also, and they focused the entire last year on the pre-calculus course that they have. So if you're thinking of resources or other structural pieces around the program, they would be able to provide some additional information. We'll eventually go there. We decided to start from Calculus 1, go up to Calc 2, and we'll eventually cycle back to pre-calc. But I don't think Omaha or Boulder are there yet. There's one other thing I want to mention, and that hasn't been brought up as a question, but I don't want it to leave here being understated. Eric did mention that there's a course that GTAs, graduate teaching assistants, take to prepare them to teach calculus. In their first semester, they take that course. They're required to take that course before they are the instructor of record for the 24 different calculus sections or the 14 other Calc 2 sections. Having that in place, having some opportunity for professional development is absolutely critical. And so before this meeting, I was at the MTEP annual meeting out in Fullerton, and everyone that was there going around the table talking about approaches that work, and Chris Rasmussen was also there talking about features of successful calculus programs. Professional development for the instructors of record is really a key piece. So if you're thinking about ways to improve a program, instructors have to have in my belief, instructors have to have firsthand experiences with the content they're about to teach in the approach that you expect them to teach it with. They need to value inquiry-based learning based on experiences that they've had with it, modeled by an instructor. So it's one thing to say this is where we're going and here's the materials that do it, but I really believe you need to consider putting those opportunities in place for instructor learning. I'm not suggesting that you don't have that in place, but it just came to mind with you discussing your program. And it's also really critical to work together. We're in teams that can share resources across 5 campuses. And actually this last week we grew to 13 in terms of just the active learning and math group. So collaboration is really helpful. It's really difficult to do this solo.
And I will add just a little plug for Stan's IBL workshop if you're interested. I think the workshop is full this summer. Stan, correct me if I'm wrong. Is it full this summer? But next summer, look for it in the future. Inquiry-based learning workshop usually comes through MAA prep or advertised to the AIBL. Check the media for that. And one addition to the trig question is some of our activities that we actually, because David said at the beginning of the presentation, we start off by doing IBL. So they get an idea right when they walk into the classroom that you're going to be active in here. We have created some activities that are pre-calc activities, so you could use those in your classes that we have on that website there. I think our function placemat, the trig dominoes one that we just created, and there's a couple more. So there's not as much as we would like, but we do have a start because we need them in calculus also.
I've got a question about the training for the learning assistants. That we have LAs here at UT Austin, and some of them are really helpful, and some of them really don't know what they're doing. And what advice would you give for providing some training if, given that we don't have the commitment to have them go through a semester course or anything like that, like you do with the TAs, but what's a quick and dirty way to get LAs up to speed?
So I'm going to defer to Eric on this since you were coordinating the LA effort in the math department for a time.
Quick and dirty way to get LAs up to speed. The LAs, so I guess it depends what you mean by up to speed in terms of sort of buying into the program and being with it and being enthusiastic about it. They're there already. That's been our experience. In terms of getting them up to speed in the material, well, it's a learning process for the LAs as well as for the students in the class. I mean, the LAs are rusty on some of their mathematics, but by the time the semester is over, they know it a lot better. And the students react very positively to having some support by somebody who's closer to the mathematics than we are as instructors.
Well, it wasn't so much concerned with being up to speed on the math, but up to speed on how to interact with the classroom and actually be a useful presence.
Right. Well, so most of that, most of that happens in the School of Education Pedagogy seminar that they are required to take. All of our LAs are required to take a seminar in the School of Education.
It's a one-credit course.
It's a one-credit course, and the emphasis in that course is certainly on, I guess, pardon the cliche, but sort of being the guide on the side rather than the sage on the stage. In our experience, learning assistants catch on to that much quicker than do many of our faculty, and certainly, to be honest, many of our graduate students who learn math the way we learn mathematics, right? And they're not really necessarily comfortable at first blush with guided kind of learning.
It also helps if they've been in your class in an active learning class. We've learned that if we've hand-selected those students, and my learning assistant now actually didn't like the active learning at first, but he grew to like it and is now a math major. And I didn't have to really tell him much because he knew what a learning assistant was supposed to do or what I did. So he learned from the modeling and just being there. And we don't have that bigger program yet, so hopefully eventually we will have a class for them to take. But until then, kind of hand selecting the people in your classrooms, and they've already seen it modeled and they do it naturally then. And I keep stealing the mic from Sue. TJ has to let us know when we're done with questions too.
Okay, I'm Sue DeRay from Augsburg College in Minneapolis. I very much appreciate the presentation and look forward to borrowing resources. I do have something that I'm not sure if I should ask as a question or a comment, because it can be very challenging questions. So let me try it as a comment. It would be most useful if I had accessible versions of all of your activities. What I mean by accessible is versions that work with students with disabilities of all different kinds. So I guess my question is, where are you in that process? Is that a nice way to ask it?
Give me some examples of which kinds of adaptations to the activities.
Well, a very obvious one is for a student who has limited sight or perhaps no sight, are there tactile versions of the graphs available, or do you work with the software for that? Because there's nothing easy that I know of that works for that.
We have not done that as an example, no. But in terms of, we haven't explored that yet. I mean, these were just designed starting last year, many of these. So, but I think some of the project activities, they're not necessarily rendered with many graphs, so it would be easier to convert those over to more tactile forms of reading. So some would be better candidates to convert and adapt than others. But we have not done that ourselves.
Is that in the works to do more of that?
Where did Eric go?
He sat down.
We would love to do more of that if we had, when we have time and resources.
Yeah. I mean, part of the issue is we didn't know how long it would take to get stable resources and materials. So to move to adaptation before the resources were somewhat stable, we didn't have to, we want to make sure all the mistakes are flushed out, right? But once they're stable and we find them to be good and useful activities, then I think an additional investment of resources would be worthwhile and absolutely necessary.
And anyone is welcome to take on any of these projects. There is not an infinite amount of time, even though we think there is sometimes, but if this sounds like something that you want to take part in, we're going to put them up online. You can take it, adapt it, send us what you have adapted, and we'll add it to the website. Everything we want free and available to share and hopefully to get better over time.
Question.
We have a question over here.
Paul Forrester from San Antonio. For those of you who are interested in pre-calculus stuff and also calculus stuff, I have information available, several hundred classroom activities in both subjects that you are welcome to use. And if you see me afterwards, I can give you information. You must be willing, however, to use something that was written by a high school teacher.
Angie, we have a question over here. I think this is going to be our last question.
Thank you, Angie. Lee Mahavier Peterman, currently unaffiliated but available to mentor anyone. This is more of a comment in answer to the lady from, I think she said, Wisconsin. Notice that the cards that we did need no further adaptation at all to be perfect for limited English proficient students. They're all graphs. The only words in there are vocabulary words such as periodic and undefined. You wouldn't have to do one thing for this to be perfect for limited English proficient.
Well, and including the integral dominoes that you saw, there's even less academic language on there. It's all representation. So we're mindful of that, and we have a more significant Hispanic population at our university.
Yeah, and it does, and it helps, especially if you have freshmen, it helps those English language learners learn English while they're doing this, because they're talking to other students and they're developing that language skills as well. Just a last kind of note, we wanted to just sample different types of activities. So we have matching, and you can turn anything into a matching activity. You can turn anything into dominoes. We have some projects. I do a lot of worksheets in my class that might not look like IBL to anybody else but me, and my students know how they're supposed to do those in their class because it's modeled, and over time they learn that. And if you come up with a different type of activity, let us know. Even if it's just a type and you don't know what to turn into that. We have some grade this quiz things where students have just anything that gets them thinking, and us telling less and them learning more on their own and thinking more on their own. So just hopefully this will jog your ideas, get some memories, some ideas, and let us know. Share with us, and have a good time at the conference. There's a lot of stuff going on, and it's always a fun couple days.
If you'll join me in thanking Eric, David, and